Hello everyone, I would like to welcome you to this DecarbCH lunch seminar. My name is Matthias Speich. I am a research associate at the Institute of Sustainable Development at the ZHAW, and I'm happy to get this opportunity to tell you about our contribution to the DecarbCH project, which will be to look at the challenge of decarbonization of heating and cooling from a socio-economic perspective. Our agenda for today. First, I would like to frame the challenge that we're looking at from a sociotechnical perspective. And next, as there is, of course, more than one way to approach the energy transition from a socio-economic point of view, I would like to present you our concepts that we work with, especially the business model and ecosystem concepts, and also to present you the methods that we're working with. And in the end, I would also like to give you a sneak peek of an ongoing project that we have, a study called SERENDIP, where we examine the decarbonization of industrial process heat in Switzerland. You can see here how we interact with the other participants of the DecarbCH project. We are, of course, working closely with our research partners with a technological focus. And as you can see, we share a non-technical work package, which is work package 02, with our colleagues from ZHAW, also from ZHAW, who are dealing with the legal framework and solutions. And it was originally planned that we would have a joint lunch seminar, but we then came to the conclusion that it made more sense that we each present our own activities. So there will be another lunch seminar from our ZHAW colleagues on the legal aspects. As far as I know, the date will still need to be determined. From our side, if we should summarize our research questions, it would be how to integrate solutions that are techno-economically and also environmentally sensible in the regional energy system so that we can achieve a timely implementation. As you know, time is a critical factor for our project, as well as a sustainable operation once these systems are in place. To start and to present the challenge that we are dealing with, I will zoom out and go to the national level. What we see on this slide is the time series of the final energy use for space heating in the residential sector in Switzerland. So these are statistics published yearly by the Federal Office of Energy. And what we can see if we look at the development over the last 20 years is first, for the good news, we see that the final energy use is sinking. And what we can also see is that there is less and less oil, which is the black part of the bars, less and less oil that is being used for space heating. On the other hand, what we see on the right side of this graph is what decarbonized heating supply would look like. So this is the data from the latest energy perspectives, also from the federal government. So this gives you some scenarios of what a decarbonized heating system would look like. And at the very right, we see a business as usual scenario with current policy and framework conditions. So what we see is that current conditions are not enough to reach the target of net zero by 2050, meaning that we will need some rather radical changes in the system to make sure that we can reach this goal. An important point here since this is one of the focus areas of DecarbCH project, the amount of energy to be distributed through district heating under these scenarios from the energy perspectives is expected to double or triple. The second thematic focus area of the DecarbCH project is the industrial process heat. For this, unfortunately, I couldn't find a time series divided by energy carriers. The time series that we have and that we show here is the final energy use divided by temperature level. And we can see that this is a fairly stable development, both for total energy use, but also for the different temperature levels. What we see is the distribution by energy carriers for the latest year where we have data, which is 2019. And from this, we can see that roughly half of the final energy use for industrial processes is provided by fossil fuels. We have on one hand high temperature applications where the challenge will be to find suitable alternatives to natural gas. On the other hand, in the lower temperature applications, this would be the application for heat pumps or solar thermal applications. The challenge here is that we are seeing a rather slow diffusion of these technologies. We all know that we have technological options to decarbonize a fair share of what we have seen. What we will be concerned with is to find strategies to deal with the non-technical barriers for their implementation. On this slide, we have summarized the most common non-technical barriers for thermal grids and also for decarbonization of industrial process heat. And I would like to highlight 3 of them. It was not an easy choice. It was not an easy task to choose 3 to highlight, as all of them are important. But the first one I'd like to highlight is the financial risk. So these are, of course, large investments, long-term investments. So there's always the question of who will carry the financial risk or how this risk is distributed. A second point I would like to highlight are competing interests, which is an issue that often arises when we are coordinating or realizing complex projects like a thermal grid. And the third point I'd like to highlight is the mismatch of customer value and societal value. And we can summarize it like this. Decarbonization is a priority of the society, but it's not necessarily something that the end customer is willing to pay for. So as you can see, we have a quite good inventory of what barriers there are. And what is now the challenge in DecarbCH is to understand them in the concrete context of Swiss districts or of Swiss industrial companies, and to find suitable strategies to deal with these barriers. As I said before, there is more than one way to approach the energy transition from a socio-economic point of view. In our group, the focus that we have, as you can see here on the top of this scheme, is on long-term value creation within regional energy systems. So we'll be talking about value networks and ecosystems and innovative business models. Now, a business model is something that we all have heard about, but something that's not always well defined. So I would like to take some time to clarify what we mean with business model, especially as an object of research. You might already have come across this figure, which comes from a widely used framework to analyze and design business models from the St. Gallen Business Model Navigator. Without going into the details, what this figure tells us is that a business model is a heuristic tool to describe, to map the logic how a company or how an organization creates value. And this concept is applicable to organizations or also to individual products. For example, you could ask, what does this utility have for a business model? Or it might make more sense to ask, if this utility wants to build a thermal grid in this neighborhood, which business model should it use to realize and to operate this grid? A business model is always a snapshot in time of how an organization operates under given environmental conditions, so that when this environment changes, a business model should always be re-examined, redesigned, or even replaced. And the last important point I'd like to make about business models is that we are not only talking about private companies that are working for profit, but any type of organization like a government agency or a non-governmental organization can also thought to have a business model. And the value that they create and provide is not necessarily monetary, but it's still something that we can describe with business model approach. Now, how can the business model concept help us in the context of a socio-technical transition, such as the transition from a fossil fuel-based to a renewables-based heating and cooling system? I would like to show you what research says on the possible roles that business models can take in such a transition context. On one hand, you can think of existing business models as barriers to change. If you think, for example, of a conservative utility saying that this is how we've always worked, it works for now, so we are not going to change how we work. This is something that is a barrier to the diffusion of technological innovations that might actually be superior from a techno-economic point of view. On the other hand, a business model is also something that you would use to commercialize a technological innovation. And depending on which business model you use, the role of this new technology can be quite different. Or you can also think of business models as complementary innovations that are not necessarily dependent on a new technology, but that can still take the role to challenge the dominant logic and thus to accelerate the diffusion of new technologies. Now we've seen that the business model concept can be useful in such a transition context. There are, of course, limitations to this concept, and one important limitation here is that a business model is always focused on how a single organization creates value. Even though it is recognized that, of course, this organization needs to interact with partners, with customers. You might remember the non-technical barriers that we've talked about before. And if we look at these barriers, we often see that this is not something that a single organization can handle or can overcome. So we need the collaboration of different organizations in order to effectively address these barriers. Now the question is, how can we as researchers with a business model focus make a contribution in such a case where we have this need for coordination, where we have value creation not only for the customers, but also on the level of society. So for this systemic innovation perspective. For this, I would like to introduce a related concept, that of the business ecosystem or innovation ecosystem. You can see graph that visualizes this concept, we are not only talking anymore about a single organization, but a network of organizations that together create value. And an important part or an important feature of such an ecosystem is the purpose and the orchestrated collaboration. So it's not just a bunch of organizations that happen to be connected or working together, but there's always this concept of orchestration, that one of these organizations has the initiative and the lead and is responsible for coordinating and orchestrating how these organizations work together. And another important point about this ecosystem perspective is that it gives an explicit place to actors from the public sector, which can be on one hand regulator. They can also be active participant, so a government agency can be one of these organizations in this value network. They can also have the role of the orchestrator. And on a more general level, the public sector is a representative of the interests of society. So if we try to organize the value creation on different level with such an ecosystem perspective, we might start with the value proposition to the end customer, which can be households or industrial companies, which are typically interested in affordable and reliable energy supply. For some of them, clean energy supply might also be important. And what can also be attractive to them is a reduction of the planning and administrative effort. If we go up one level, we arrive at the business value, which is the logic of how an individual organization can provide this value. For example, a utility is interested in making profitable or at least even investments in clean heating and cooling solutions. And in some cases, you could say this is already enough. This is enough to describe the relationship between customers and business. But in many cases, and of course also in the cases where we need additional research, this is more complex. You might have additional actors in the system. For example, you can think of an industrial company who is interested in providing waste heat as an input. You can think of an ICT service provider in the context of digitalization of the systems. So there are many cases where you could think of more complex value networks. And this is the next level that we'll be looking at in this perspective. So what is the value of extending this network and collaborating with additional actors? And on top of that, we have the level of the societal value. An important goal is, of course, a timely achievement of the net zero target. Another something that is valued by society is that the value creation stays in the region. And this is typically something where the authorities have the responsibility to coordinate. Now that I've introduced the concepts that we work with, I'd like to briefly introduce our methods. Our primary data collection techniques are, for example, surveys, interviews, or experiments such as choice experiments. We often work in a participatory setting, so with close involvement of the stakeholders. And another methodological approach that we are working with is system dynamics, which allows us to perform simulations of the socio-technical systems that we are interested in. Now, as I mentioned, we often work in a participatory setting. So we closely involve the stakeholders that we're working with, for example, in workshops. And the aim is that we want to, of course, understand the roles that these different actors fulfill. We want to understand how they see the system or which challenge they see. We also want to analyze where they see themselves in a value network or an ecosystem that I've shown before. And the idea is not only to understand what is currently going on, but also to find potentials for improvements of how can these different organizations work together differently, or is there a need for involvement of additional actors that can contribute something new. So to summarize, the idea is to elaborate and assess innovative business models for the integration of the heating and cooling technologies that we are interested in DecarbCH. So the idea is very much to involve the stakeholders to find solutions jointly, rather than simply coming as the university and telling them what they should do from an academic perspective. So we actively involve their expertise and their perception of where they see opportunities or barriers. In a typical case study, for example, like the case studies that are planned in DecarbCH Work Package 6 or 7, our contribution could look like this. We are, of course, working with the tasks that are anyway ongoing or planned by the city. And our role will be, on one hand, that of an observer, which would accompany these different tasks and regularly or iteratively try to see where we could improve, or where the city or the different organizations have room for improvement, or how the governance of the whole value network or the ecosystem is currently, and whether there is a scope for improving it, either by defining some additional rules or questioning the current rules, how these organizations work together, or by bringing in new actors that can provide something new that the current system is not able to provide. With, of course, the end goal of providing a timely, or of achieving a timely integration of the renewable energies or of the grid technologies that we are interested in DecarbCH. Something that we will also be working on, as I've briefly mentioned before, is the use of simulation models to be able to better understand these socio-technical systems that we're interested in, and to be able to assess the prospects of the solutions that we elaborate together with stakeholders. If we take the example of thermal grids, you could think of it as follows. We would elaborate the simulation models of the local energy system, which would be, for example, at the scale of a district to be supplied with this thermal grid. And we would model some processes like customer decisions. So at each time step of the simulation, for example, at every year, we would have a number of customers who need to decide whether they want to join this grid or whether they want to replace their current heating system with another decentral solution. And these decisions will have network effects. They will, for example, influence the economics of the whole grid. They will also influence the requirements for the infrastructure to be built. So these are the kind of feedback loops that we want to capture with the simulation model, so that we would have basis to describe what can we expect will be going on in this system. And the idea is that such a simulation model can be adapted to the local context. So we would need to change some parameters describing the concrete neighborhood so that we can apply the same model to different local contexts. We would be able to test different solution variants, so we could think of different variants of a concrete business model. And we also want to test these variants under different scenarios, so to be able to address this uncertainty. For example, we don't know how future demand will look like. We don't know how technology or energy prices will evolve. We don't know what future policies will be in place. So as a way to deal with this uncertainty, we would conduct what if scenario analysis. And the outputs of the model, these are, of course, the KPIs that we are interested in. For example, greenhouse gas emissions, how fast are we able to reduce them over time? But also, for example, cash flows. So what does this mean for the financial balance of, for example, the utility, of the customers, or of other actors involved? Now I've promised that I would give you a sneak peek into our ongoing study, SERENDIP, which is a study that is complementary to the DecarbCH project, in that we study the drivers and barriers of decarbonization of industrial process heat within the specific context of Swiss manufacturing companies. And the aim is to identify the need for either further instruments. For example, is there a need for additional policies or additional consulting offers? Or in general, to find out what is needed to accelerate the uptake of measures to decarbonize industrial processes. This study is internally financed, and it's running over this year, so there will be a report coming out at the end of the year. And the idea is also to make it the basis for a periodical survey in the future, where we would have a barometer of industrial decarbonization in Switzerland. The study design that we use, we are starting with a literature review. So on one hand, we review the known barriers and drivers of industrial decarbonization, and we set these barriers and drivers within the context of management theory. So here, for example, we use a widely used framework, the Sankala management model, to locate these barriers within the specific processes and interactions of a company with its surroundings, but also of what is happening inside the company and influences the decision-making process. Based on this review, we developed an interview guide, and we are now in the process of conducting interviews with decision makers in the Swiss manufacturing sector. And this is an iterative process where we are conducting the interviews. We are selecting from the population, the total population, which is all manufacturing companies with an emission target agreement. And as we perform the interviews, we already analyze the content, and this is the basis for the decision. Do we need some additional interviews, or did we reach a point where we have a saturation, where we don't expect any new information from new interviews? So this is where we are now. Since this is an ongoing study, I cannot really present you any secured insights or conclusions yet, but this was just to show you the design of the study that's ongoing. What we can show you is an example for how we proceed with coding and content analysis. What we are doing now is that we are going through the transcripts of each interview and assign each statement made by the interviewees to a certain topic or to a certain code. So as an example here, we have 2 statements made in an interview about the topic of internal financing. So on one hand, we have the statement that says, well, financing is always an issue. We are supposed to invest or to spend on something, and we don't know yet if it will pay off. We have to be extremely careful with this. And another statement in the same interview, which is also about internal financing, is that they mentioned some possible solutions like federal support or also a leasing solution. So what we are going through now is to assign all the statements made in the interviews to different codes. And based on the pattern we see in these codes, so what are the main statement, the main issues regarding internal financing, for example, or how does it interact with other issues or with the company characteristics? We will synthesize the insights we get from the interviews, which will have, of course, implications both for theory and also for practice. Now, after this brief excursion, I would like to wrap up and present you the take-home message of today. We have seen that the decarbonization of heating and cooling provides value creation opportunities, not only to businesses, but also at different levels to citizens, to the state, and to society in general. And to realize these value creation opportunities, we will need new forms of orchestrated collaboration between organizations and new business models. This is where our ecosystem perspective comes in. And from a methodological point of view, the solutions to transform the energy system and to realize these value creation opportunities is something where we will need an iterative approach and also a close collaborations with the practical partners and also, of course, the technology-oriented researchers. I would like to thank you for your attention.